Hello everybody, welcome. This is our final video in this set of 35 problems of an AP Physics C Mechanics multiple choice test. So we finally reached our last video. Congratulations if you stuck with this all the way through. This is really going to help you in your preparations for the test. So this is the third in a set of 3 problems relating to this scenario. I'll read it quickly and then jump into our last problem. An object is initially hanging in equilibrium from a vertical spring. The object is pulled down 15 centimeters from its equilibrium position and released at time t equals 0. The object then oscillates with a period of 2 seconds. This is simple harmonic motion, remember. Now, problem 35. Which of the following statements is true of the magnitude of the acceleration of the object at time t equals 1 second? And our options are A, it equals 0, B, it equals G, C, it has its minimum value that is not 0, and D, it has its maximum value, and E, it has a value between 0 and its maximum value. So what we're looking at here is trying to find the magnitude of the acceleration at a certain time. So there are many different ways we can solve for acceleration. In terms of different variables, we have stuff like force equals mass times acceleration. You can solve acceleration in terms of like projectile motion, such as ones where we have like v equals v naught plus at, all of these, but these are not going to come in handy here. The equation that we're going to need for this problem is actually not on the useful equations sheet. There might be another way to solve this problem without that equation, but by far the easiest way is with this, so you should probably memorize this one. It's pretty helpful in situations like these. It is A, acceleration is equal to negative omega squared, omega being that rotational velocity, times x. X is the displacement. So this is the equation that's going to help us for here. So it is true of the magnitude of the acceleration of the object at time t equals 1 second. So let's pause for a second and look at our omega, our angular velocity. We're specifically looking at the object at time t equals 1 second. From the last video, we know that at t equals 1 second, this is going to be all the way at the top of its path. It's going to be at positive 15x. So at 1 second, we know x is going to be positive 15. That is its maximum value. For omega, we don't really know what it's going to be. We could figure it out, but we don't even need to figure it out for this problem. The goal in these multiple choice problems is to get the answer by doing the least possible amount of work. And for this problem, that means not having to solve for omega, just knowing that it's going to be a constant value. It's going to be, whatever omega is going to be, it's going to be some negative number. So it's going to be negative whatever and times positive 15. So that means our acceleration, since x is at its maximum, that means that a is going to be negative, because we're multiplying this negative omega squared times x. So it's going to be negative, and then since this is the maximum, it's going to be at its minimum, because it's this negative constant times its maximum. So it's going to be negative something, which will be its minimum value. So let's look at the answers we have here and see how it compares. It equals 0. Nope, it's going to be negative. It equals G. No. It has its minimum value that is not 0. Alright, that looks like a pretty good answer. Let's look at the other ones and come back to it. This little plus sign, I just write these on multiple choice tests. It means I think this is right, but I'm going to come back to it. So D, it has its maximum value? No, we just found out that it has its minimum value because Although x is at its maximum, we're multiplying it by a negative constant. So no, it has its minimum value, not its maximum. It has a value between 0 and its maximum value. Nope, the value is not going to be above 0 because it's going to be negative. So yes, it looks like C is indeed our correct answer. Again, this equation for acceleration in terms of angular speed and x in terms of displacement is not on the useful equations sheet, so this is one that you guys should memorize. Yeah, this is how to solve this problem to get, well, we didn't fully solve it because we did not solve for omega, but that's okay because we can figure out the answer without solving it, and it's even better to do that because you're going to save yourself time on the test. So, thank you for watching. We're done. Thank you guys, and good luck on the test. If you've come this far all the way, that's awesome. If you haven't, go back and watch the other ones. They will help you out. I appreciate it, and good luck on the test.